Hello everyone, welcome to the session. In this session, we'll see about projectiles. Okay, before that, we'll recap the previous session. In the previous session, we'll see the motion of a particle under gravity. Okay, and that motion is a linear towards the gravity or Earth, right? But in this session, we'll see about the projectiles. First, we'll see what is projectile. A particle projected in the air in the direction other than vertical. So it is not in a vertical direction. The particle is not moving in a vertical direction like in your previous session, right? So that is oblique to the direction of the gravity. See, for example, this is your direction of gravity. Your projectile will be in this particular direction. That means you should be making some oblique with respect to the direction of right, or else see, this is your horizontal one. With respect to this, your projectile is making some path, right? So your projectile is oblique to the direction of the gravity is called projectile. Okay, once again, a particle projected in the air in the direction other than the vertical. So here the particle is there, it is projected in the air, but it is not in a vertical direction, it is oblique to the direction of a gravity, is called a projectile. And the path traced by that particular particle, see, when you are just throwing that particle into the air with some oblique to the direction of gravity, then that particular path is trajectory. Okay, and what is this curve? We call parabola. Okay, it is, the curve is parabola and the path we call it as a trajectory one. Okay, the path traced by the particle is trajectory, but the curve is parabola. And the next one, the most important point in this, here the horizontal component of initial velocity. See here the horizontal path is there, and now from this particular point you thrown one projectile into the air. Here it is making velocity in this direction, what, which is like u, but you have another velocity in the direction horizontally, it is like ux, right? And you have another component which is u y, right? So it is actually what you're projecting into the air with velocity u, and this is your absolute velocity, and ux is the absolute velocity in the horizontal direction, and this is your velocity in the vertical direction. Okay, and now what he's saying here, the horizontal component of the initial velocity remains constant. That means this particular one will be always constant. See here, so here at this particular point again you have a horizontal one, horizontal velocity is there, and this horizontal velocity is also ux, but your vertical component here it will changes, which is like y, and that equals to 0. That means at this particular point it is a maximum point, right? At maximum point your velocity is 0. And now, so as the particle is going on like this, so your total horizontal force will be a constant, but your vertical force will changes from point to point. From everywhere your vertical velocity will changes, but not the horizontal velocity. Horizontal velocity is remains constant. Clear? Horizontal component of the initial velocity remains constant, and the vertical component change as same way as in the motion under gravity. So in the previous session we'll seen this motion under gravity, right? So at there the vertical component is goes on changing from place to place. In that way this projectile also will changes with respect to the gravity, but your horizontal component will never changes, it will remains constant. Clear? And we'll see a few terms in this projectile. See, first one is velocity of the projection. His velocity is u. The velocity with which the projectile is projected into the space is called velocity of the projection. And the next one is projection, angle of projection. That means, see, horizontal line is there, or horizontal a floor is there, from particular point if you thrown a particle, and this is the angle of projection with respect to the horizontal surface. The angle made by the direction of projection with horizontal is called angle of projection, right? With horizontal, clear? And the next one is horizontal range, the horizontal distance, see, and from here where it is reached the ground is your total distance, right? And this distance we call it as horizontal range. You can see here, horizontal distance traveled by the projectile during its flight is called horizontal range. So you are representing this as r, so this is your total horizontal range, clear? And now we'll see some formulas. So now we'll see some formulas. Motion of a projectile, see, this is your first one, which is like equation of trajectory. This is your y component in particular point, and this is your x coordinate. Like, see here, for example, if your particle is here, here you have the distance of x, right? From here to here you have the distance of y. So these are the coordinates of this particular particle at this particular point. So x and y are the coordinates. Tan alpha minus gx square divided by 2u square cos square alpha. Alpha is your angle of projection, u is your velocity, okay? And next, this is your acceleration due to gravity, and these are the coordinates, okay? And next, coming to the next formula, maximum height attained by a projectile. So that means this, in this total path, this is your maximum height, right, from the ground level, from the ground surface, and this is your maximum height, and that maximum height is given by u square into sine square alpha divided by 2g, which is the velocity of the particle, angle of projection, and this is acceleration due to gravity. And moreover, and the velocity at this maximum point is equals to 0. You can see at maximum height your velocity is 0. And the next, the time required to reach maximum height. So you already seen these projections. At this particular, the time required to reach this maximum height is u sine alpha by g, and this is your velocity, and this is your angle of projection. The final velocity is when the particle is, or projectile is reached here, and this is your velocity at the final point, which is like final velocity v equals 0. And the next, time of flight, that means from point of projection to point of uh, target is your time of flight, which is t equals to 2u sine alpha by g. 2u sine alpha by g. This is your time of flight. That means the total time taken by the projectile in its path. At the end, the time at the end t, your height is 0. Okay, at this particular point your height is 0, right? And now this is your horizontal range. You already seen this. See, from here to here, from the point of projection to from the point of reach to the ground is your horizontal range, and you are designated as r. For that, formula is u square sine 2 alpha by g. And the previous one is, which is like maximum height, like for the maximum height, okay, it is for maximum height, u square sine square alpha by 2g. But for this it is u square, it is not sine square, it is sine 2 alpha by g. Don't confuse with maximum height and the horizontal range. And to get the maximum range, that means to reach the maximum distance, we require one condition, which is like alpha should be 45 degrees. So from in this total formula, if this value, which is like sine 2 alpha, if it is maximum, your range also maximum. So the sine 2 alpha is maximum like 1. So if you simplify this, what you're going to get is alpha equals to 45, and if you substitute the same thing in this formula, you're going to get R max is equals to U square by G. Clear? And this is your maximum range, okay, by the condition of alpha equals to 45 degrees. Clear? And now we'll see a small problem on these projectiles. Okay, a projectile is aimed a mark on a horizontal plane. See, on a horizontal plane, he just assumed one target from the point of projection. See, we don't know that. Okay, what is the distance and all. Mark on a horizontal plane through the point of projection. It falls 12 meters short when the angle of projection is 15 degrees. See, when the angle of projection is 15 degrees, okay, it reaches 12 meters short. Okay, this is 12 meters. See, just think that the total distance of target is S. Okay, and now this distance is S minus 12. Why? Because it falls 12 meters short, okay, before your target. So when the angle of projection is 15 degrees. So this is your first condition, okay. And while it overshoots marked by 24 meters, that means when it is overshooting the particular target, so it is reaching 24 meters beyond your target, which is like 24, when the same angle is 45. So this angle is 45. Find the angle of projection to hit the mark. So we need the angle of projection, which is like alpha, to hit this target. Assume no air resistance. No, there is no air resistance. Clear? We'll see the figure now. See here. See, this is your actual target, and which is of distance S. And this is the first case, which is like when your angle is 15 degrees. When your angle is 15 degrees, it is shortfall to 12 meters. From here to here, it is 12 meters. So the distance from here to here is S minus 12. This is 12. Okay. So now it is overshooted to 24 from the target. So from here to here, it is overshooted when the angle is 45 degrees. So from here, so now this total distance is S plus 24. So, and the total problem is based on the range, right? From here to here, it is a range. From here to here, range. Here to here, range. So first we'll see what is this range formula. Range of projection is given by the expression like R equals to U square sine 2 alpha. It is not sine square alpha divided by G. It is sine 2 alpha. Clear? And now we'll keep applying one case and later another case, and applying it to the first case, which is like your distance. See, this is the range formula, which is like distance R is S minus 12 for the first case, U square by G sine 2 alpha. Alpha is 15 degrees for the first case, right? When it is shortfall to the 12 meters. So if you simplify this, you are going to get the first equation. And from the second case, it is S plus 24. Okay, you can see the figure, and if you substitute the value of angle for the second case is 45 degrees. If you simplify this, you're going to get this U square by G. And now from the equation 1 and 2, what you're going to get is, if you simplify these two, equation 1 and equation 2, you're going to get S plus 24 equals to 2 of S minus 12. That means this is 2 times, right? Like here it is like 2G, here only G. So by that you're going to get this S equals to 48. Clear? And next we'll see correct angle of projection be alpha. Then see, same the total range what we get now is S equals to 48 equals to U square by 2G sine 2 alpha. Why you're taking this means now we require this alpha when your distance is 48. So if you substitute that, and from the equation 2, if you substitute the value of s equals to 4 in that equation 2, what you're going to get is u square by g is equals to 72 meters. Okay, once again, if you substitute s equals to 48 in equation 2, you're going to get u square by g equals to 72 meters. And if you substitute that 72 meters here, okay, 48 is equals to 72 sine 2 alpha, you're going to get this alpha value, which is 20.905 degrees. So when your target is at distance of 48, then your angle should be 20.9 degrees. Yeah, thank you.